Hi, hello there. Welcome to Inter-VLAN routing. Now you know how to segment and organize your network into VLANs. Hosts can communicate with other hosts in the same VLAN. And you no longer have hosts sending out broadcast messages to every other device in your network, eating up needed bandwidth. But what if a host in one VLAN needs to communicate with a host in a different VLAN? If you are a network administrator, you know that people will want to communicate with other people outside of your network. This is where inter-VLAN routing can help you. Inter-VLAN routing uses a layer 3 device such as a router or a layer 3 switch. Let's take your VLAN expertise and combine it with your network layer skills and put them to the test. Let's get started. So this video lecture is entitled Inter-VLAN routing. Now the objective of this video lecture is that at the end of this video lecture, you should be able to troubleshoot inter-VLAN routing on a layer 3 devices. So topics includes inter-VLAN routing operation, router on a stick inter-VLAN routing, inter-VLAN routing using a layer 3 switches, and troubleshooting inter-VLAN routing. Inter-VLAN routing operation. So what is an inter-VLAN routing? VLANs are used to segment switched layer 2 networks for a variety of reasons. Regardless of the reason, hosts in one VLAN cannot communicate with hosts in another VLAN unless there is a layer 3, right, or a router, okay, to provide routing services. So we're talking about layer 3 switches here. So inter-VLAN routing is the process of forwarding network traffic from one VLAN to another VLAN. So there are 3 inter-VLAN routing options. So these are the legacy inter-VLAN routing, okay, the router on stick, and a layer 3 switch using a switched virtual interfaces or SVIs. So the legacy inter-VLAN routing, this is a legacy solution and it does not scale well. So router on a stick, this is an acceptable solution for a small to medium-sized network. And the layer 3 switch using an SVI or the switched virtual interfaces, this is the most scalable solution for medium to large organization. Legacy inter-VLAN routing. The first inter-VLAN routing solution relied on using a router with multiple Ethernet interfaces. So each router interface was connected to a switch port in a different VLANs. The router interfaces serves as the default gateways to the local hosts on the subnet or VLAN subnet. So for example, refer to this topology here where R1 has 2 interfaces connected to switch S1 here. Okay, so notice in the example MAC address table of switch 1, and it is populated as follows. So the FA01 port is assigned to VLAN 10 and is connected to R1 G0/0/0 interface. Now FA011 is assigned also to VLAN 10 and is connected to Pc1. Okay, FA0/12 that is assigned to VLAN 20 and is connected to R1 G0/0/1 interface. And the last one would be FA0/24, which is connected to Pc2, okay, and is a member of VLAN 20. Okay, now when Pc1 sends a packet to Pc2, all right, so for instance, we will be sending data from Pc1 going to Pc2 here, okay. So take note that it is on a different network. So Pc1 here is using 192.168.10.10 and is located on VLAN 10. Whereas your Pc2 is located on 192.168.20.10 or at VLAN 20. Okay, so the thing is, when PC1 sends a packet to PC2 on another network, it forwards it to its default gateway, which is at 192.168.10.1. Okay, now R1 receives that packet on its G0/0/0 interface and examines the destination address of the packet. Now R1 then routes the packet out its G0/0/1 interface to the FA0/12, okay, port in VLAN 20 on S1. So finally, S1 forwards the frame to PC2. Legacy inter-VLAN routing using physical interfaces works, but it has a significant limitation. So it is not only reasonably scalable because routers have limited number of physical interfaces. So requiring one physical router interface per VLAN quickly exhausts the physical interface capacity on a router. Alright, now in R1 here, okay, so in R1, this required two separate Ethernet interfaces to route between VLAN 10 and VLAN 20. So what if there were 6 or more VLANs to interconnect? So basically that's a problem. Okay, so a separate interface would be required for each of the VLAN. Obviously, this solution is not scalable. Alright, now imagine if you have 20 VLANs here, then you need 20 physical interfaces. Okay, so that makes it not scalable. Now take note that this method of inter-VLAN routing is no longer implemented in switch network and is included for explanation purposes only. Router on a stick inter-VLAN routing. The router on the stick inter-VLAN routing method overcomes the limitation of the legacy inter-VLAN routing method. It only requires one physical Ethernet interface to route traffic between multiple VLANs on a network. So a Cisco IOS router Ethernet interface is configured as an 802.1q trunk, okay, and connected to a trunk port on a layer 2 switch. So specifically, the router interfaces is configured using a sub-interface, okay, so to identify a routable VLANs. So the configured sub-interfaces are software-based virtual interfaces. Each is associated with a single physical Ethernet interface. Sub-interfaces are configured in software on a router. Each sub-interface is independently configured with an IP address and VLAN assignment. Sub-interfaces are configured for different subnets that corresponds to their VLAN assignment. This facilitates logical routing. So when an inter-VLAN or when a VLAN tag traffic enters the router interface, it is forwarded to the VLAN sub-interface. Okay, so after a routing decision is made based on the destination IP network address, the router determines the exit interface for the traffic. Okay, now if the exit interface is configured as an 802.1q sub-interface, the data frames are VLAN tagged with the new VLAN and sent back out to the physical interfaces. Alright? So the figure here shows how a router on a stick performs its routing function. Okay? Now as seen in the animation, so PC1, okay, so which is at 172.168.10.21, okay, is communicating with PC3 on VLAN 30 with 192 or 172.17.30.23. So when R1 accepts the tagged unicast traffic on VLAN 10, it routes that traffic to VLAN 30 using the configured sub-interfaces. Okay, now switch 2 removes the VLAN tag of the unicast frame and forwards the frame out to PC3 on port FA0/23 here. So take note that router on a stick method of Inter-VLAN does not scale beyond 50 VLANs. That's the limitation of a router on a stick. Inter-VLAN routing on a layer 3 switch. So the modern method of performing inter-VLAN routing is to use a layer 3 switches and switched virtual interfaces, or SVI. An SVI is a virtual interface that is configured on a layer 3 switch, as shown here in the figure. Alright, so we have an SVI interface, member of VLAN 10, and another SVI interface, which is a member of VLAN 20 here. So take note that a layer 3 switch is also called a multi-layer switch, as it operates at layer 2 and layer 3. However, in this course, we use the term layer 3 switch. Alright, so Inter-VLAN SVIs are created the same way that the management VLAN interface is configured. So the SVI is configured or created for a VLAN that exists on the switch. Although virtual, the SVI performs the same functions for the VLAN as a router interface would. Specifically, it provides layer 3 processing for packets that are sent to or from all switch ports associated with that VLAN. So the following are the advantages of using a layer 3 switch for the inter-VLAN routing. Okay, so they are much faster than router on a stick because everything is hardware switched and routed. There is no need for an external links from the switch to the routing to the router for routing. There are not limited to one link because layer 2 Ethernet channels or Ether channels can be used as trunk links between the switches to increase the bandwidth. Okay, so latency is much lower because data does not need to leave the switch in order to be routed to a different network. They are more commonly deployed in a campus LAN than routers. So the only disadvantage is that layer 3 switches are more expensive. Router on a stick inter-VLAN routing. In the previous topic, there are 3 different ways to create an inter-VLAN routing. Okay, and these are the legacy inter-VLAN routing was detailed. Okay, now this topic details how to configure a router on a stick inter-VLAN routing. You can see in the figure, okay, so that the router is not in the center of the topology. Okay, so but instead appears to be on a stick near the border, hence the name. Okay, now in the figure, R1 gigabit Ethernet 0/0/1, okay, interface here is connected to S1 FA05 port. Now the S1 FA01 port is connected to S2, okay, so via FA01 port. Now these are the links that are required to forward traffic within and between VLANs, and we call it trunk, okay, or trunk links. Now to route between VLANs, so the R1 gigabit Ethernet 0/0/1 interface is logically divided into 3 sub-interfaces as shown here. So we have sub-interface 1.10, 1.20, and 1.30. So the convention is this 10, 20, and 30 here corresponds to a VLAN. Now in this example here, VLAN 30 or sub-interface 1.30 corresponds to 99. But in our practice, okay, for the laboratory, so we are using the VLAN number as the sub-interface number. All right. Okay, now as what I'm saying, to route between VLANs, this R1 gigabit Ethernet 0/0/1 interface is logically divided into 3 sub-interfaces. Alright, so you're gonna have a sub-interface virtually for VLAN 10, for VLAN 20, and for VLAN 99 in this example. Alright, so S1 VLAN and trunking configuration. Okay, now complete the following steps to configure switch 1 with VLANs and trunking. So there are basically 4 steps here. Okay, so first, create and name the VLANs. Second, create the management interface. Third, configure access ports. And fourth, configure trunking ports. Alright, so let's start with the step 1 here. Create and name the VLANs. Okay, first, the VLANs are created and named. From the previous video lecture, we've talked about VLANs, how to create VLANs and how to name it. Okay, so VLANs are commonly or are only created after you exit out of VLAN subconfiguration mode. So this is how we configure VLAN and name it. So for switch 1, that would be VLAN 10, then give it a name. In this case, that's LAN 10. Alright, so exit VLAN 20, name LAN 20. And for instance, you've got VLAN 99 here, name management. Alright, so after creating and naming the VLANs, so the second step is to create the management interface. Okay, so the management interface is created on VLAN 99 here, along with the default gateway of R1. Alright, so the configuration says interface VLAN 99. Let's put an IP address 192.168.99.2. Alright, subnet mask is /24 255.255.255.0. Okay, no shutdown. And then exit. Let us apply a default gateway here. So the command would be IP default gateway 192.168.99.1. Okay, so again, why are we assigning an IP address on a switch? That is for management purposes. So step 3 is configure the access ports. Okay, so port FA06 connecting to Pc1 is configured as an access port in VLAN 10. Now assume Pc1 has been configured with a correct IP address and default gateway. Okay, so on the switch, interface FA06, switch port mode access, switch port access VLAN 10, no shutdown, exit. Okay. Alright, so next would be configure the trunking ports. So finally, ports FA01, okay, that is connecting to switch 2, and FA05 here, that is connecting to R1, are all configured as trunk ports or trunk links. So how do we configure this? So you go to interface FA01, switch port mode trunk. Alright, no shutdown, exit. Also, we need to configure FA05 here. So switch port mode trunk, no shutdown. Okay, so afterwards, there would be notification that the interface is up. Alright, so this is the summary of the configuration we have just made on the recent slide. So the configuration is similar on both switches. Okay, so how about the R1 sub-interface configuration? Okay, now the router on a stick method requires you to create a sub-interface for each of the VLAN to be routed. The sub-interface is created using the interface ID, sub-interface ID, okay, global configuration mode command. The sub-interface syntax is the physical interface followed by a period and a sub-interface number. so which is usually our VLAN number. Although not required, it is customary to match the subinterface or the subinterface number with the VLAN number. That is for easy identification. Okay? Now, each subinterface is then configured with the following two commands here. So you've got encapsulation.1q VLAN ID native. This command configures the subinterface to respond to 802.1q encapsulated traffic from the specified VLAN ID. Okay? Now, the native keyword is optional. Okay? So the native keyword option is only appended to set the native VLAN to something other than VLAN 1. Alright? Next would be the IP address. IP address subnet mask. Okay? Now, this command configures the IPv4 address of the subinterface. This address typically serves as the default gateway for the identified VLAN. So we need to repeat the process for VLAN or for each of the VLAN to be routed. Each router subinterface must be assigned an IP address on a unique subnet for routing to occur. Now, when all subinterfaces have been created, enable the physical interface using the no shutdown interface command. Okay? And then if the physical interface is disabled, all subinterfaces are disabled. Now, in the following configuration here, the R1 G0/0/1 subinterface are configured for VLAN 10, all right, VLAN 20, and VLAN 99, which is our management VLAN. Okay? Now, the configuration is as follows here. Okay, so on R1, so go to the interface G0/0/1.10. So we are also going to create the subinterface for VLAN 10. Okay, description is optional, encapsulation.1q, and then the VLAN number. So since this is for VLAN 10.1q10, all right, and then assign an IP address from VLAN 10 block. Okay, so in this case, this is 192.168.10.1 /24 255.255.255.0. Okay. Next, interface G0/0/1.20. So this is the subinterface for VLAN 20. Okay. So encapsulation.1q20 IP address 192.168.20.1 /24. So that would be 255.255.255.0. Okay. So let us create the third subinterface, which is for VLAN 99. So, and that would be interface G0/0.1 or /1.99. So encapsulation.1q VLAN number, which is 99. IP address 192.168.99.1 255.255.255.0. Okay. Next would be go to G0/0/1 interface. All right. And then we have to issue the no shutdown command. So if we fail to do this, so all the subinterfaces are shut down. So after G0/0/1, turn it on with no shutdown command, you've got some notifications here that this subinterfaces here, okay, will also going up after the physical interface went up. So this is the summary of the configuration displayed in the previous slide here. All right, so after the configuration, so the next thing to do is to verify connectivity between Pc1 and Pc2. Okay, now the router on a stick configuration is complete after the switch trunk and the router subinterfaces have been configured. So the configuration can be verified from the hosts, right, routers, or a switch. So from host, verify connectivity to a host in another VLAN using the ping command. Okay, now it is a good idea to first verify the current host IP configuration using ipconfig, okay, as shown here. All right, so ipconfig, that will display the assigned IP address, okay, the subnet mask, and the default gateway. Okay, so next, we use the ping command to verify connectivity with PC1 and switch 1 as shown in the figure here. Okay, the ping output successfully confirms that inter-VLAN routing is operating. All right, now the output here confirms the IPv4 address and default gateway of PC1. All right, so you'll have it there, and then it should be able to ping. Router on a stick inter-VLAN routing verification. So in addition to using ping between devices and using also the ipconfig first before you do the ping, okay? Now the following show commands can be used to verify and troubleshoot the router on a stick configuration. Okay? You've got the show IP route, show IP interface brief, show interfaces, and show interfaces trunk. Let's get into it one by one. All right, so for the show IP route, okay, so verify that the sub-interfaces are appearing in the routing table of R1. Okay, so that would be by using the show IP route command. So notice that there are 3 connected routes here denoted by C. Okay, C meaning connected routes, and their respective exit interfaces for each routable VLANs. So the output confirms that the correct subnets, VLANs, and subinterfaces are active. All right. So the next one would be show IP interface brief. So another useful router command is this show IP interface brief. Okay. Now the output here confirms that the subinterfaces have correct IPv4 address configured and that they are operational. All right, you've got the status there, up and up. Next would be show interfaces. Sub-interfaces can be verified using the show interfaces sub-interface ID, okay, as shown here. So show interfaces G0/0/1.10. Okay, so the next command is show interfaces trunk. The misconfiguration can also be on the trunking port of the switch. Okay, therefore, it is also useful to verify the active trunk links on a layer 2 switch by using this show interfaces trunk command. The output confirms that the link R1 is trunking for the required VLANs. Okay, so take note that although VLAN 1 was not explicitly configured, it was automatically included because control traffic on trunk links will always be forwarded on VLAN 1. Inter-VLAN routing using a layer 3 switches. So modern enterprise networks rarely use what you call router on a stick because it does not scale well easily to meet the modern requirements. Okay, now in this very large network administrators use layer 3 switches to configure inter-VLAN routing. Now inter-VLAN routing using the router on a stick method is simple to implement for small to medium-sized organization. However, a large enterprise requires a faster, much more scalable method to provide inter-VLAN routing. Okay, so enterprise campus LAN uses a layer 3 switches to provide an inter-VLAN routing. So layer 3 switches use hardware-based switching to achieve higher packet processing rates than routers. Now, what are the capabilities of a layer 3 switch? Okay, to include the ability to perform. Okay, so based on the requirements. First, route from the VLAN to another using multiple switched virtual interfaces. Okay. Second is to convert a layer 2 switch port on a layer 3 interface, example routed port. Okay. A routed port is similar to physical interface on a Cisco iOS router. Third is to provide an inter-VLAN routing. Layer 3 switches use SVIs. Now, SVIs are configured using the same interface VLAN ID command used to create the management SVI on a layer 2 switch. So, a layer 3 SVI must be created for each of the routable VLANs. Now, let's have here a layer 3 switch scenario. Now, in the figure, the layer 3 switch, which is denoted by D1 here, is connected to two hosts on a different VLAN. Okay, so one from VLAN 10, all right, and maybe one from VLAN 20 here. Okay, now the layer 3 switch will provide an inter-VLAN routing services to the two hosts. Okay, so that means Pc1 here will be able to ping Pc2 even though they are on a different VLANs. So let's have the layer 3 switch configuration for this topology here. Okay, so it includes several steps. So first, create the VLANs. In the example, VLANs 10 and 20 are used. Okay. Second, create the SVI VLAN interfaces. The IP address configured will serve as the default gateway for hosts in the respective VLAN. Third, configure access ports using the appropriate port to the required VLAN. And step 4, enable IP routing. So how? We issue the IP routing global configuration command to allow traffic to be exchanged between VLAN 10 and VLAN 20. So this command must be configured to enable inter-VLAN routing on a layer 3 switch for IPv4. All right, so let's get into that steps. Okay, so step 1 was to create the VLANs. Okay, in the example, that would be VLAN 10 and VLAN 20. So that would be on the switch, VLAN 10 name, let's name it LAN 10, VLAN 20 name LAN 20 exit. So with this one, we have successfully created VLANs and name it accordingly. So step 2, all right, so create the SVI VLAN interface. The IP address configured will serve as the default gateway for hosts in the respective VLANs. So we've got two VLANs here, VLAN 10. All right, so interface VLAN 10, assign an IP address. So in that case, 192.168.10.1. Okay, and then that is /24, so that would be 255.255.255.0. No shutdown. So create another SVI. Okay, so in this case for VLAN 20, so IP address 192.168.20.1, 255.255.255.0, and then no shutdown. All right. So configure the SVIs for VLAN 10 and 20 here. The IP address that are configured will serve as default gateways to both hosts in their respective VLAN. So take note that we have some informational messages here showing the line protocol on both SVI changed to up. So that means it is now operational. All right. So step number 3 is configure access ports. Okay. Configure access ports connecting to the hosts and assign them to their respective VLANs. So how is it? So interface, okay. In this case, for instance, that is G10/6. Switch port mode access, switch port access VLAN 10. Okay, you do the same on the host for VLAN 20. So that would be interface G0 or G10/6 018. All right, VLAN 20. Switch port mode access, switch port access VLAN 20, and then exit. Okay? All right, so the last one would be to enable IP routing. So finally, enable IPv4 routing with the command IP routing global configuration command to allow traffic to be exchanged between VLANs 10 and 20 here. So this command must be configured to enable inter-VLAN routing on a layer 3 switch for IPv4. Layer 3 switch inter-VLAN routing verification. Inter-VLAN routing using a layer 3 switch is simpler, okay? So rather than or compared to a router on a stick, okay? So after the configuration is complete, the configuration can be verified by testing connectivity between the hosts. All right? So from host, verify the connectivity to a host in another VLAN using the ping command. Okay? Now, it is a good idea to first verify the current host IP configuration using the ipconfig command. All right? Now, the output here confirms that IPv4 address 192.168.10.10, okay, with a subnet mask, and of course the default gateway set, which is 192.168.10.1. So afterwards, verify connectivity with Pc2 using the ping Windows host command. Now the ping here, okay, verifies that we have successfully connected these two computers from different hosts. All right, so this output here confirms an inter-VLAN routing is operating. Routing on a layer 3 switch. If VLANs are to be reachable by other layer 3 devices, then they must be advertised using static or dynamic routing. So to enable routing on a layer 3 switch, a routed port must be configured. Okay? A routed port is created on a layer 3 switch by disabling the switch port feature on a layer 2 port that is connected to another layer 3 device. So specifically, configuring the command no switch port, okay, interface configuration command on a layer 2 port converts it into a layer 3 interface. So take note that it is a switch, and therefore it is on switch port mode. So that's why when we execute no switch port on the interface, that would become the routed port. Okay? Now the interface then can be configured with an IPv4 configuration to connect to a router or another layer 3 switch. Routing scenario on a layer 3 switch. Now in the figure, the previously configured D1 layer 3 switch is now connected to R1. Okay? R1 and D1 are both in an OSPF or Open Shortest Path First routing protocol domain. Okay, so as you can see here, this is an OSPF network. Now assume Inter-VLAN has been successfully implemented on D1. The G0/01 interface of R1 has also been configured and enabled. So additionally, R1 is using OSPF to advertise its two networks here. Okay, so given here. Take note that OSPF routing configuration is covered in another course. In this module, OSPF configuration commands will be given to you in all activities and assessments. So it is not required that you understand the configuration in order to enable OSPF routing on a layer 3 switch. All right? Routing configuration on a layer 3 switch. So we need to complete the following steps to configure D1 to route with R1. So we have 5 steps here. Configure the router or routed port with, of course, the command no switch port command to convert the port to a routed port and then assign an IP address and subnet mask to it. Okay, we have to enable the port. Second, enable routing. Use the IP routing global configuration command to enable routing. Third, configure routing. So use an appropriate routing method. In this example, we will be using the single area OSPF version 2 configuration. Fourth, verify routing. So how? Show IP route. Okay, and then afterwards, verify the connectivity with ping. Okay, so let's get into the detail. So first step was configuring the routed port. So how is it? Configure G101 to be a routed port and then assign it an IPv4 address and enable it. Now to do that, for instance, you've got interface G0/0/1. Okay? And then no switch port. So after the no switch port command, we can now assign an IP address, in this case 10.10.10.2. Alright, so 255.255.255.0. And then no shutdown. So the second step is to enable routing. So that is simple as IP routing. Okay, step 3, configure routing. Alright, now configure the OSPF routing protocol to advertise VLAN 10 and VLAN 20 networks, along with the network that is connected to R1. So notice the message informing, okay, so that you have performed adjacency and established with R1. Okay, so you'll have this notification if you have successfully established adjacency on the neighbors. Okay, now to configure OSPF on D1, so the command would be router OSPF 10 network. Okay, so these are the directly connected networks, all right, on D1. And that is all on area 0. So the configuration of this OSPF is not part of the course. All right. So, but then if you're going to continue the coverage or the course, so you're gonna have configuration of the OSPF for this course. Okay, so step 4 is to verify routing. So verify the routing table on D1. Notice that D1 now has a route to 10.20.20.0/24 network. Okay, so this would be our routing table here. Now, those denoted by O here means it was learned from an OSPF network. Okay, so next, afterwards, after we verify the routing table, so the next would be verify the connectivity. So at this time, Pc1 and Pc2 are able to ping the server connected to R1. Troubleshoot inter-VLAN routing. Common inter-VLAN issues. So by now, you know that when you configure and verify, you must be able to troubleshoot. Okay? This topic discusses some common network problems associated with inter-VLAN routing. There are a number of reasons why an inter-VLAN configuration may not work. All are related to connectivity issues. Okay? Now, if the connections are correct, then use the list in the table for common or other common reasons why inter-VLAN connectivity may fail. Okay, so these are the issues here, and we are going to go into details about this issue type, how to fix, and how do we verify using this router configuration or show router configurations. Okay, so the show commands. So the issues includes missing VLANs, switch trunk port issues, switch access port issues, and router configuration issue. Now, how to fix it? on the missing VLANs, we need to create or recreate the VLAN if it does not exist. Okay, so ensure host port is assigned to the correct VLAN. So we can verify that using show VLAN or show VLAN brief. Okay, or show interfaces switch port, and also test the connectivity using ping. Now, the switch trunk port issues can be fixed by ensuring trunks are configured correctly. Ensure port is a trunk port and enabled. So how to verify that? Show interface trunk or show running config. Next would be switch access port issues. So how do we fix this? Assign a correct VLAN to access port. Ensure port is an access port and enabled. Host is incorrectly configured in the wrong subnet. So we can use this show commands here, something like show interface switch port, show run interface or show running config interface, and then ipconfig. Okay, so next would be router configuration issues. So how to fix this? Router subinterface IPv4 address is incorrectly configured, so you have to check that using the show Ipinterface brief. Okay, or router subinterfaces is assigned to the VLAN ID, so you use show interfaces command on that. All right, so troubleshoot inter-VLAN routing scenario. Examples of some of these inter-VLAN routing problems will now be covered in more detail. Okay, now this topology here will be used for all these issues. Okay, the VLAN and IPv4 addressing information for R1 is shown in the table here. So we've got 3 subinterfaces here, and then of course the VLAN number. All right. Missing VLANs. An inter-VLAN connectivity issue could be caused by a missing VLAN. The VLAN could be missing if it was not created, or it was accidentally deleted, or it is not allowed on the trunk link. For example, Pc1 is currently connected to VLAN 10, okay, as shown here on the show VLAN brief command output. Okay. Now assume that VLAN 10 is accidentally deleted as shown in the following output here. So for instance, right, so no VLAN 10 to show VLAN brief. So if you will observe, VLAN 10 is not anymore on the configuration. Okay. So notice that VLAN 10 is now missing from the output presented earlier. Also notice that port FA06 here, okay, has not been reassigned to the default VLAN. The reason is because you deleted a VLAN. Any ports assigned to that VLAN become inactive. They remain associated with a VLAN and thus inactive until you reassign or assign them to a new VLAN or recreate the missing VLAN. Okay, so take note, FA06 is not in here. It was associated with VLAN 10 from the previous slide here. Okay, when we deleted it, for instance, accidentally deleting it, so there is no VLAN or there is no FA06 on the default. Okay, so that means it is still associated with the deleted VLAN. Okay, now what we can do is we use the show interface ID switch port command to verify the VLAN membership. All right. Next, recreating the missing VLAN would automatically reassign the host to it, as shown in the following output here. Okay, so for instance, we are going to create VLAN 10. Again, take a look at, we don't have VLAN 10 and FA06 is still associated with a deleted VLAN. Now recreating it, okay, so VLAN 10 and then afterwards do show VLAN brief. Okay, so if you will observe here with that command, VLAN 10 was recreated, FA06 is associated with it. Now if you will observe, we did not name the new VLAN or recreated VLAN 10. So it uses the default VLAN number, so VLAN 0010. Okay, so you might want to change this VLAN name here. Switch trunk port issues. So another issue for inter-VLAN routing includes misconfigured switch ports. In a legacy inter-VLAN solution, this could cause when a connecting router port is not assigned to the correct VLAN. However, with a router on a stick solution, the most common cause is a misconfigured trunk port. For example, assume Pc1 here was able to connect to hosts in other VLAN until recently. So a quick look at the maintenance logs revealed that S1 layer 2 switch was recently accessed for routine maintenance. Therefore, you suspect the problem may be related to that switch. Okay? Now on switch 1, verify that the port connecting to R1, okay, which is FA05 here, is correctly configured as a trunk link using the show interface trunk command, as shown here. Okay, so that is FA05. Okay, and on switch 1, FA01. Okay, so FA01 is in there. Okay, so this has been on using the encapsulation 802.1q, and trunking is there. Okay, the FA05 port connecting to R1 is mysteriously missing from the output. Okay, have you noticed that? So in here, the FA05 is not indicated. Okay, so you only see there FA01. All right, now verify the interface configuration using the show running config interface FA05 as shown here. Okay, so interface fast Ethernet 05 switch port mode trunk shutdown. All right, so as you can see, the port was accidentally shut down. So to correct the problem, re-enable the port and verify the trunking status as shown in the output here. So you need to go to the interface FA05 and then no shutdown. To reduce the risk of failed inter-switch link disrupting inter-VLAN routing, redundant links and alternate paths should be part of the network design. Switch access port issues. When a problem is suspected with a switch access port configuration, use verification commands to examine the configuration and identify the problem. Assume Pc1 has the correct IPv4 address and default gateway, but is not able to ping its default gateway. Okay, Pc1 is supposed to be connected to VLAN 10 port. Verify the port configuration on switch 1 using the show interfaces interface ID switch port command as shown here. Okay, so this is FA06, it's enabled, and you can see there you've got static access. Okay, now let us back to the configuration file. Okay, so that is show run interface FA06. Okay, it says here switch port mode access. Okay, you've got FA06 here that is connected to Pc1 and it is set to switch port mode access. Okay, now the FA06 port has been configured as an access port as indicated by static access. Okay, now however, it appears that it has not been configured to be in VLAN 10. So verify the configuration on the interface. Assign port FA06 to VLAN 10 and verify port assignment. So PC1 is now able to communicate with hosts on other VLAN. In this case, PC2. Okay? Router configuration issues. So router on a stick configuration problems are usually related to sub-interface misconfigurations. For example, an incorrect IP address was configured or the wrong VLAN ID was assigned to the sub-interface. For example, R1 should be providing inter-VLAN routing for users in VLAN 10, 20, and for instance VLAN 99 here. However, users in VLAN 10 cannot reach any other VLAN. Okay, now you verify the switch, okay, with a switch trunk link and all appears to be in order. Verify the sub-interface status using the show IP interface brief command here. All right. Now the sub-interfaces has been assigned the correct IPv4 addresses and they are operational. Verify which VLANs each of the sub-interfaces is on. To do so, we use the show interface command. Okay, that would be useful, but it generates a great deal of additional required output. So the output can be reduced using the iOS command filters as shown in the output here. Okay, so this is a command filter. All right, so something like show interfaces, all right, pipeline include gig 802.1q here. Okay, now the pipe symbol along with the select keywords is a useful method to help filter command output. In this example, the keyword include was used. Okay, so to identify that only lines containing the letters gig or 802.1q will be displayed. Because of the way the show interface output is naturally listed, using these filters produces a condensed list of interfaces and their assigned VLAN. You don't want to see all those configurations set on the switch or on the router. So that's why we're using this filter commands. Okay. Now notice that G0/0/1.10 okay, has been incorrectly assigned to VLAN 100 instead of VLAN 10. Okay. Now, so this is confirmed by looking at the configuration on R1 gigabit Ethernet 0, okay, /0/1.10. Okay, so take note, you've got encapsulation .1Q100. Okay, so to correct this problem, configure subinterface G0/0/1.10 to be on the correct VLAN using encapsulation .1Q. This should be 10. Okay, so as you can see here, so we need to go to the interface and then encapsulation .1Q10, replacing 100 with 10. All right. So notice that G0/0/1.10 interface has been incorrectly assigned to VLAN 100 instead of 10. This is confirmed by looking at the configuration on R1 G0/0/1.10 subinterface as shown here. Okay, so it's in the previous slide. Now, to correct this problem, we set it to 10. Okay, now when the subinterface has been assigned to the correct VLAN, it is accessible by devices on that VLAN, and the router can perform inter-VLAN routing. So with verification, router configuration problems are quickly addressed, allowing inter-VLAN routing to function properly. Okay? So that's the end of this video lecture. Thank you very much and have a great day.